Okay, really quick, just in case, because that video might have been too long to actually be posted to YouTube, the previous video I just recorded. If you missed it, and the explanation of what all that code does, too bad, man. I don't know. If you really want the explanation, which I don't think anyone's actually going to watch this, but if somebody actually does want an explanation and thinks that I could actually give them some insight, then I don't know, PayPal me some money and I will give you an explanation. I will sit down there and talk with you. But yeah, so right now we have our all the code we did in the previous playlist is now implemented in OpenGL. And so if you see this right here, that is, if we go into editor number 1, so this is editor number 1, and there's different shaders within editor 1 because editor 1 is our sample shader. If we look at this slot here in editor 1, and if we zoom out, we will see something kind of familiar. Let's just reset. Okay, so resetting the project. This is the default shader. This is the shader for the master editor. Here is editor 1, and this is a view of the tile as uniform values. And so these black and white values are the different values that have been encoded as uniforms into the texture. And then, this right here is editor number 2. And we can zoom in and out of all the data. And we have a 512 by 512 section of pixels that we're looking at, but we're rendering them as kind of like these shaded squares to prove that we can actually calculate the internal coordinates of the tiles so that we have all the math ready for if we wanted to blit sprite images onto these tiles, right? And so we can zoom in and out and check this out. See that color change? That's pretty cool, but it's not actually a color change, right? It's just that the movement here is, there's no animation when you move, right? So, so when I'm moving up and down, so I move up to the left, down, up, right? It can be hard to know that you're actually moving, but the camera is moving, but it is snapped to the tiles. Okay, so if I change the buffer subsection that I'm looking at by changing the hot swapping index, we can move all the way up to the top left memory cell. And hey, that looks kind of interesting. Let's zoom into that. That looks really interesting. That looks kind of familiar. Let's go over to editor number 1 again. Editor 1, editor 2, editor 1, editor 2. Yes, it's the same stuff. We're looking at the data section. When I work on my editor, I could actually, when I'm working on the editor, I'm going to want to lock off. So zooming out, this whole area, this whole 512 by 512 section is for the game's memory. I want to lock this off from the editor, like add some actual code that does not allow the editor to go here. Because if we keep this, I mean, we could have like a way to turn the safety off, but basically I'm going to make it so that, we can click things here and like change their tile value. If we change the tile values here, we'll actually be like, we're like poking around in the brain of the game right now. These are actually the game variables stored as pixels within the VRAM. So if we're like in the tile editor and we go over to this section of memory that we shouldn't be messing with and we start popping down tiles, we will corrupt the memory of the game, and weird things will happen. And that could actually be kind of fun. But it'll also be kind of bad. It's like, it's almost like game sharking yourself, This is a very colorful hex editor, basically, for the running process. So with great power comes great responsibility. Don't touch it. So what else? So this is testbed shader number index 1 in editor number 1. This is a little Mandelbrot, and there's your data in editor number 1. Data in editor 1, the data as seen in editor 2. What else? So the last thing I just want to go over is so within here, we can zoom into this Mandelbrot. We can't zoom in too far because we are using these inclusive rectangles to form sub-selections of data. And the smallest that rectangle can be is 1 pixel or 1 frag, I guess, in size. So we can't zoom in too much. I think this is about as far as we can go. Okay. And then once we go too far, we end up back on the other side. So everything goes inverts. And the reason everything inverts here is because the rectangle that's zooming, it flips over on itself because the controls... I have 2 different style methods for manipulating the viewport rectangle, and right now I'm using the unsafe version, the unbounded version that doesn't do any air checking. So we can do weird things like go out of bounds. Like I could go out of bounds with this camera as well. So when I'm talking about how far you can zoom, if we go over to editor 2, right? So when we're zooming, right, as far in as you can zoom is, well, let's go to somewhere where there's actually data in the top corner, or data that we can see. So let's go over here. So as far in as you can zoom is this, right? 1 pixel, right? So zooming out, zooming in. So you can, the furthest you can zoom out right now is the entire buffer of data. So this is the entire memory cell, the entire 512 by 512 subsection of memory on the mastery memory segment. And we can zoom out to see it all, or we can zoom in to see just 1 pixel of that data. But that's all the zoom level we have. Right? I'm doing everything with integer math, and that's all it's going to support. If I want to support more zoom than that, I have some ways I could do that and still keep the math integer. Basically, we would have another viewport. I'm going to call it like a deep port. So here's our viewport where we can change the size of the viewport, and then, yo dog, I heard you liked viewports, so we put a viewport in your viewport, right? So you would have another viewport called the deep port, which is a viewport within the viewport, and you use that for like the next level of zoom. When you want to zoom further than, like, we want to zoom into this, we're going to need a viewport that is for this now. I don't know if I've explained that very well, but the point is that I want to make sure all of the math is integer logic, especially because all of the data is encoded in pixels, right? All the game data is encoded in these pixels. So if we try to use floating point algorithms when we're encoding everything as uint32s, oh boy, we're going to be in some trouble. But everything is just everything is a bit pattern, right? Even floating point numbers. But just to keep things simple, everything's going to be integer logic. So yeah, there we go. So we've finally gotten the previous playlist code to work as WebGL code. And that took a long time. But that's because we wrote a lot of framework. So woo, isn't that fancy and rewarding? All right, yay, all right, cool. So this is the last video. Like, because we're not over our time limit, so this is definitely going to make it up to YouTube without getting an error that it's too long. But we're done. I've finally got a lot of groundwork. I might stop doing videos now for this because I'm getting into the parts that are proprietary. Like, I have some ideas that have never been done before. I've scoured the internet to make sure, and I have some ideas that have not been done before. I'm going to go do them and make something awesome. But you know what? Feel free, like, if you want to use this as a starter project, go ahead. Like, I'm going to post this on Pastebin. Go ahead and use it. But it's just that I might not take this these videos any further, just because the tech that I'm working on I want to keep proprietary, and I'm not even going to show off the tech, because if I show off the tech, it's going to be obvious what it's doing. It's going to be obvious what it's doing if I show off the tech. You'd have to be a relatively talented coder to make it happen. But it's like if you showed off Minecraft to somebody, right? Then it's very easy to clone Minecraft after you show it to people, because somebody who's reasonably proficient in coding will be like, oh, that's an interesting idea, I can code that. Same thing with the tech I'm working on. Like, it's never been done before. It's a really cool idea. But if I even demonstrated it, then I would lose my competitive advantage. So basically, you know, I want to be the first one to work on this. Had a head start. So I've been generous. I'm going to show you this stuff. Maybe you can get started on your own thing, but hopefully now you know a little bit more about how to do viewport math in WebGL and in Canvas. So now if you need a game that needs viewport logic and camera logic, hopefully maybe you've gotten something out of this, but whatever. All right, see you later.